Today we're going to talk about the true costs of generative AI for the enterprise, specifically focusing on large language models. And it's important for an enterprise to consider all of the costs beyond simply subscribing to a chatbot LLM like ChatGPT. I'd like to start with a quick story. Last week, I was at a wedding and no one could find the best man. We were in the dinner and the rehearsal, and all of a sudden, he came out of the back room with his laptop, and he was in this back room writing his best man speech on his laptop using ChatGPT. And you know what? It came out fantastic. For consumer use, like writing a last-minute speech or a funny poem, using a consumer chatbot is awesome. And that's why, for the consumer use case, spending under $25 a month for access feels like a great deal, because it is. But we're comparing enterprise use versus consumer use. For the enterprise, we have to safeguard what we're putting into production when we're dealing with sensitive, confidential, and proprietary data. Now, it's essential for the business to evaluate working with a platform, partner, or vendor that is geared towards the enterprise. And this comes with very different cost factors than the consumer. Today, we're going to touch on 7 of these important cost factors that influence how to scale generative AI across the enterprise. Number 1, use case. What is it that you actually want to do with generative AI? Number 2, model size. What type and parameter size of the model are you leveraging? 3, pre-training costs. Are you looking to build an LLM from scratch? 4, inferencing. This is the cost of generating a response using the LLM. 5, tuning, which is the cost of adapting the pre-trained model to do new tasks. 6, hosting, which is the cost of deploying and maintaining that model. And then 7, deployment. Are you going to be deploying in the cloud, on SaaS, or on-premise? Now, these are all areas to consider, and the first that we're going to cover is use case. Now, I can't tell you how often I have sellers, customers come to me and ask me to create a blanket statement for what generative AI is going to cost them for their enterprise. And what I say to that is that this is very similar to walking into a car dealership and asking how much a vehicle is going to be. Different use cases will require different methods and are going to drive different amounts of compute. We need to understand, are you looking for a convertible, a truck, off-roading, leather interior? We need some specifics. And my recommendation here is to work with a partner or a vendor that allows you to participate in a pilot so that you can identify all of your pain points and first see if generative AI makes sense as a solution. This will give you the opportunity to really workshop out what it needs to test and evaluate for your enterprise. Play around with different models. See what delivers the best efficacy at the lowest cost and the fastest speeds. If you have access to an entire workbench of models and numerous tuning methods, you won't be locked in, and you can do what's right for your enterprise and truly customize that. Now, we're going to move on to our second cost driver, which is evaluating model size. Now, when we talk about model size, the size and complexity of the generative AI model can really impact pricing. And what we see here is that the larger the model is, the more parameters it has, and that's going to drive compute and different resources. So what we'll find is that vendors will offer different pricing tiers based on model size. So we can look here at some examples, right? We have our smallest model here, which is Flan, where we see this at 11 billion parameters. We have Granite, which is a middle tier size at 13 billion. And then we have the largest of them all, Llama 2, at 70 billion parameters. And what's important to know is that different models are going to serve different use cases. Some are better for language translation, others are better for Q&A. And as you move across different models, you have the opportunity to assess what's going to best suit your use case. So something to look out for when assessing a vendor or partner to work with is what's their stance on model access. Specifically, are they locking you into one model for every use case? Or do you have the option to select what works best for you? Another thing is to assess whether or not they're continuously innovating on their own proprietary models. We found that innovation at the model level can actually provide you with some key advantages when it comes to domain-specific task generation and experimenting with different parameter sizes. Now we're going to go to our third cost driver, which is pre-training. This is the process of building and training a foundation model from scratch. Now, if we look at what this means, it's been very cost prohibitive for a lot of enterprises to do so because it requires a tremendous amount of compute time and effort. And while this does give enterprises the control of the data used to train an LLM, it does come with a cost. We can look at something that everyone's familiar with, GPT-3. And if we look at what some of these cost factors were, it was over 1,000 GPUs over a 30-day period. And what this particular 30-day period cost was over $4.6 million. So we can see that this is very, very expensive and really why we only see a few key players that have emerged on the marketplace to take on that challenge of pre-training LLMs from scratch. So if you're not going to pre-train, you can certainly leverage and take advantage of an LLM that's already been pre-trained. So now we'll move on to the next cost factor of working with a pre-trained LLM, which is inferencing. And when we talk about inferencing, we are talking about the process that the model uses to understand the prompt question and the process that it uses to generate a response. So essentially, this is how the model figures out what it is that you want and then uses its own knowledge to create the answer. Inferencing operates on a discrete unit of information that we call a token. And this is a common industry term where one token roughly equates to 3/4 of a word. Now you can expand that out to identify that 100 tokens would equate to roughly 75 words. And if you're still trying to figure out what that benchmarks into, the entire work of Shakespeare would come out to roughly 900,000 words. Now, the size of a token can vary depending on which tokenizer you use. Tokenizer refers to the tool that actually converts the text to a token, but 3/4 of a word is a rough rule of thumb that you can go off of. Now, when we talk about the cost for a single inference, it's important to note that this includes the number of tokens in both the prompt and the completion, which would be the output. So important to note that it covers both of those. Now, there's one other term that's important when we're covering inferencing, and that is prompt engineering. Now, when we talk about prompt engineering, this is how we interact with the prompt itself. And this is an industry term for really the methodology used to craft effective prompts with the ultimate goal of eliciting a desired response from the LLM. What's important to note here is that it does not touch the parameters of the model itself. It's more like choosing the right words and formatting how you ask the question to really help the model better understand. And it's a really cost-effective way to achieve tailored results without extensive model alteration. And this is different than tuning because it does not require the high compute resources or any of the hosting. So now we're moving on to cost factor number 5, which is tuning. Now, when we talk about tuning, we're talking about the process of adjusting the internal settings or parameters of the model itself to really improve performance. Tuning is measured in hours, and you'll often see that there are different hourly rate charges depending on what model size you're using. We talked earlier about how different parameter sizes lead to different cost increases. Now, when you're making the decision to tune, there may be 2 reasons why you would choose to do so. So reason number 1, maybe it's to achieve better performance from your base model. When we talk about better performance, we're going to evaluate whether or not tuning the model on a large number of labeled data could really enhance performance. When we do this, we see that you can actually optimize it by bringing in your own data. The other option for tuning may be to evaluate whether or not you can lower the cost at scale by deploying a smaller model than maybe what you initially used. One thing that's really important to keep in mind here is that the cost of labeled data acquisition is a really important factor. Now, when we talk about tuning, there are 2 main functions of tuning and 2 main methodologies of how you can tune. We have fine-tuning, and then we have parameter efficient fine-tuning, otherwise known as PEFT. Now, to cover the difference between these two, when we talk about fine-tuning, we're talking about extensive adaptation of the model itself. So you're tuning all of the parameters and changing them. You're going to be generating a forked version of this base model that actually requires you to then go on and host that. And it requires hundreds of thousands of data points, of labeled data for you to bring in here. So this is ideal for highly specialized tasks where performance is critical. When we talk about parameter efficient fine-tuning, this really aims to achieve task-specific performance without the high costs that are associated with extensive fine-tuning. And this is really achieved by avoiding any changes to the model itself. So here, you could think of this as tuning smaller models by adding additional parameters, not altering what exists. So for this, you can see this more around hundreds to thousands of labeled data sources. And we see different types of cost-effective ways to apply parameter-efficient fine-tuning. Some of these types that you may have heard of may include prefix tuning, prompt tuning, p-tuning, LoRa, but these are all methods of parameter-efficient fine-tuning. So let's drive this home with an analogy. Let's say you buy a home, you move in, congratulations, everything's perfect. But after a couple of months, you discover that it actually snows quite a bit more in your environment than what you thought it would, and it gets a lot colder. And initially, you had windows that served you quite well in the summer, but now that it's winter, they no longer work. It's really drafty. So let's drive this home with an analogy. Let's say you decide to go and completely change the structure of your windows. You put new windows in that provide you with insulation, and you even get some really nice curtains to go along with that. But on top of that, it snows so much more. So now you actually have to go on and buy a ton of new equipment. You have to buy snow plow, snow shovel, snow boots, snow tires, and actually build yourself a garage to store all of this. This is an example of fine-tuning in the sense that you are making structural changes to the architecture of your house. How this would relate to the model, making structural changes to the underlying parameters. If we look at what this would mean for PEFT, well, perhaps here, you're not going to do anything to actually change the underlying structure. Maybe instead of rebuilding your windows, you put a towel under there to block the draft. Instead of building a garage to house all of your new snow equipment, maybe you reuse something you already have, and you just use your broom and use that to scrape snow away. So it's helpful to consider here that there's different methods that make sense for different use cases. Perhaps in some, we mentioned earlier, you can get everything you need in your output from prompt engineering. As you need to make your models tuned for more specific use cases, it's helpful to have different methods of doing so and working with a partner or vendor that provides you with the ability to explore different parameter-efficient fine-tuning methods as well as fine-tuning for when you really need it, because then you have the advantage of selecting the most cost-effective method for your needs. Now we're going to move on to discuss evaluating factor 6, which is when do you need to host a model? Now, there are different circumstances that would require you to actually have to host a model to then go back and interact with it in these ways that we discussed before for inferencing and things of that sort. Now, if you are going to make an LLM available for use, there are two ways to go about doing it. One would be hosting it, or one would be using an inference API, each of which becomes relevant depending on whether or not you're going to fine-tune a model. So if you're not fine-tuning a model, and you're going to use some of those earlier methods we discussed where maybe you're using parameter-efficient fine-tuning or you're using prompt engineering, this is when you can go on and use an API for inferencing. And essentially, what this means is that you're going to stay consistent with those initial cost factors that we described with the token unit of driving price and cost and compute. And here, the LLM is pre-deployed by the platform provider, and it's made available via this API. And the way to think about this is really kind of like a phone, where you are placing that call to the model to ask a question and prompt an answer, and you do this on demand as you need it. Again, as I mentioned, the cost for inference when you're using an API inference is based on the number of tokens that have been processed by the prompt plus the completion of that prompt via the API call. This, again, is used when you're not making changes to the underlying model. So you're not fine-tuning and you're not bringing something new in that's not already hosted by your platform. The other way we consider hosting is actually when it becomes relevant when you are fine-tuning or you are bringing your own model. At that point, you are required to then go and host that model because you're essentially creating either a forked version or bringing something new in. And in this case, the LLM is actually made available for deployment by the platform provider by taking this in. And so for this, you could think of it as rather than phoning a friend because they don't have access to a phone, you actually build them a room in your house, and that's where they are for easy access whenever you need to chat them up. So when we're talking about how we think about cost factors when you are actually hosting a new forked version of the model, on top of what you use with your tokens for prompting, you also have to consider in the hours that are required for hosting this model. And again, you would pay for hours based off of the amount of time that you want to interact with the model. So if this is something you need to interact with all of the time, you'd be paying the hour cost for 24/7 access to this model. Now, again, it's very important to realize that different use cases and circumstances are going to require different methods of connecting to your model. It's helpful to have a vendor or partner that actually allows you to interact with your model in numerous ways. If you do need to host it with fine-tuning, to have that option, but if you can do an API inference, to also have the ability to access it in that way as well. And now we've made it to our 7th cost factor, which is deployment. Now, when we think about deployment, every industry has different standards and every business has different needs. So we're referring to where you're putting the platform, and the cost of using generative AI can vary significantly depending on whether you choose SaaS or an on-prem deployment. So when we talk about SaaS, there are some benefits here when it comes to cost standpoint. First of all, you're using a subscription fee. This is often a predictable and managing cost structure as you're paying that recurring fee to access the AI service. You have a different approach to the infrastructure here. You're not going out and procuring your own hardware and data centers. You are avoiding that aspect of the cost. And when it comes to scalability, you have the ability to increase or decrease usage as needed. And again, all of the maintenance and updates to the infrastructure are included. The big thing here is that when it comes to generative AI, a lot of people are concerned about acquiring GPUs. With this, you don't need to go out and procure your own GPUs. The SaaS providers are actually sharing those GPU resources across multiple users, so it ends up being more cost-effective for the end user. On the other end, we have on-premise. Now, for some industries, there are regulations that require you to do things on-prem, and you're not allowed to host your data in the cloud. And for that, there are solutions out there for on-premise deployments as well. What's important to note here, though, is that you are required to purchase and maintain those GPUs, the amount of which would be contingent to the amount of compute that is required based off of your inferencing, tuning, model selection. But you do have the benefit here of having full control over the architecture and how your data is deployed. There are no black boxes. So again, depending on your use case and industry, you might have different needs. But the recommendation here is